In this video, we continue with the differentiation of inverse trigonometric functions. And the first question which we are looking at is y is equal to tan inverse of root of 1 minus x 1 plus x square minus root of 1 minus x square divided by root of 1 plus x square plus root of 1 minus x square. So this falls under the type which we discussed in the earlier video. There is no direct trigonometric formula available for tan inverse in this pattern, but it involves both 1 plus x square and 1 minus x square. So if there is no direct trigonometric formula available, and if it involves both 1 plus x square and 1 minus x square, according to the rules we discussed earlier, substitution is let x square be equal to cos theta. Now, what's the logic in saying x square is equal to cos theta? When you learn it, you need to have the proper understanding. We say x square is equal to cos theta because if you say 1 plus x square and x square is being replaced by cos theta, I'll get 1 plus cos theta, which has got a half angle formula, 2 cos square theta by 2, and 1 minus x square, but x square will be replaced by cos theta, so I'll get 1 minus cos theta. So this is 1 plus cos theta and this is 1 minus cos theta. Both 1 plus cos theta and 1 minus cos theta have got half angle formulae. 1 plus cos theta here would become 2 cos square theta by 2, and 1 minus cos theta here would become 2 sine square theta by 2. So that's the reason. So if you have both 1 plus x square and 1 minus x square involved in a question where there is no direct trigonometric formula available, then we will say let x square be equal to cos theta. So let's make that substitution now. So I'll get tan inverse of root of 1 plus x square became cos theta minus root of 1 minus x square became cos theta divided by, even in the denominator we replace x square by cos theta. Now we have this half angle formula for both 1 plus cos theta and 1 minus cos theta. 1 plus cos theta becomes 2 cos square theta by 2 and 1 minus cos theta becomes 2 sine square theta by 2 in both numerator and denominator. See here again, 1 plus cos theta is 2 cos square theta by 2, 1 minus cos theta is 2 sine square theta by 2. In the next step, when we simplify, you can see that there is a root 2 common factor in the numerator and a root 2 common factor in the denominator. So if you take the common factors out, root 2 and root 2 will cancel. So there won't be any number left here now. Root 2 gets cancelled from everywhere. Then root of cos square theta by 2 will become cos theta by 2. Root of sine square theta by 2 will become sine theta by 2. So let's write that. Tan inverse of root 2 is gone from all the four terms. Now root of cos square theta by 2 is written as cos theta by 2. Root of sine square theta by 2 will become sine theta by 2. Same thing in the denominator. Square root and the square is cancelled. Square root and the square is cancelled. Now what I'm going to do here is I'm going to try and make it match with one of the tan formulae. We know that every single tan formula has got 1 as the first term in the denominator. So if I want 1 here, I should divide each term by cos theta by 2. So I'm going to say dividing each term by cos theta by 2. So when I do that, I'll get tan inverse of cos theta by 2 by cos theta by 2, 1, minus sine theta by 2 by cos theta by 2 makes it tan theta by 2, divided by again cos theta by 2 by cos theta by 2 is 1, sine theta by 2 by cos theta by 2 is tan theta by 2. To make it match with the tan formula, I'm going to replace 1 in the numerator by tan pi by 4, which is 1. So I'll write it as tan pi by 4, 1 minus tan theta by 2 divided by 1 plus, I write this simple tan theta by 2 as 1 into tan theta by 2. But I don't write 1. I replace 1 by tan theta by 2. So look at that. Tan pi by 4 is actually 1. So this is 1 minus tan theta by 2 divided by 1 plus this simple tan theta by 2 I wrote as tan pi by 4 into tan theta by 2. So that's like 1 into tan theta by 2, which is tan theta by 2. So it's exactly the same thing, but it then looks like tan A minus tan B divided by 1 plus tan A into tan B. Tan A minus tan B upon 1 plus tan A into tan B is tan of A minus B. So this whole bracketed expression would become tan of A plus A minus B. Tan of A minus B, where A is pi by 4 and B is theta by 2. So it's going to become tan inverse of tan of A minus B, pi by 4 minus theta by 2. Tan inverse and tan will cancel. So you have pi by 4 minus half theta. I just wrote it like half theta. It's theta by 2. So tan inverse and tan got cancelled. So you have pi by 4 minus theta by 2, or half theta. And what is theta? Cos theta is equal to x square. So theta would be cos inverse of x square. We know our substitution is cos theta is equal to x square. So theta is equal to cos inverse of x square. So pi by 4 minus half cos inverse of x square. That's your y. And now I'm going to differentiate. So y is equal to pi by 4 minus half cos inverse of x square. Therefore dy by dx would be, derivative of pi by 4 would be 0 minus half, the coefficient would stay there. Cos inverse of x is 1 by root of 1 minus x square. But this is cos inverse of f of x. So would be minus 1 by root of 1 minus f of x the whole square into f dash of x. F of x is x square. So into f dash of x would be 2x. So let's look at that again. Half into cos inverse of x square. If it was cos inverse of x, it would have been minus 1 by root of 1 minus x square. But instead of x, I have x square. So minus 1 by root of 1 minus x square the whole square into derivative of x square is 2x. So 2 and 2 will get cancelled. Minus and minus is plus. So what you have is x divided by root of 1 minus x raised to 4. You need to take time to pause the video in between, go back and listen to it again, write it down carefully, and then redo it to yourself and practice it. Let's look at another question. Y is equal to cot inverse of root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. Here there is no scope for any substitution as such. But what I can see is there is an irrational expression in the denominator. So I want to rationalize it. And to rationalize it, we multiply by the conjugate of the denominator. So what's the conjugate of the denominator? It looks like root a minus root b. Conjugate would be root a plus root b. So I'm going to take the conjugate of this, which is root of 1 plus sin x plus root of 1 minus sin x. Like root a minus root b, conjugate is root a plus root b. So with the conjugate of this, I'm going to multiply both numerator and denominator. So it's going to be cot inverse of, I first copy the denominator, root of 1 plus sin x minus root of 1 minus sin x. So root of 1 plus sin x minus root of 1 minus sin x, which is my denominator, and I'll now multiply by its conjugate. Conjugate will be the same thing with plus sign in between. So that is root of 1 plus sin x plus root of 1 minus sin x. Now if I multiply the denominator by this term, I should multiply the numerator also by the same term, and that's when I realize that what I have in the numerator and my conjugate are actually the same. So if I multiply the numerator, which is root of 1 plus sin x plus root of 1 minus sin x, by the conjugate, which is actually the same thing, wouldn't the numerator now become that the whole square? Root of 1 plus sin x plus root of 1 minus sin x into itself makes its whole square. So that's what we did. We took the conjugate of the denominator and multiplied both numerator and denominator. Then the numerator became like a plus b the whole square, while the denominator is like a minus b into a plus b. So I'm going to do that simplification now. So I'll say cot inverse of numerator is like a plus b the whole square, which is a squared. When I say a squared, root will go away, so I have 1 plus sine x plus 2ab, 2 into, this is my a, root of 1 plus sine x, into b, root of 1 minus sine x. So that's my 2ab term, plus I have b square, and b square would be root of 1 minus sine x the whole square. So square root will go away. I have 1 minus sine x. So this looks like a plus b the whole square. On expansion it is a square plus 2ab plus b square. And in the denominator it looks like a minus b into a plus b, which will be a squared minus b squared. So when you say a squared, square root will go away. You will get 1 plus sine x minus b square. When you say square root will go away, you will get 1 minus sine x. In the numerator, this plus sine x and minus sine x will cancel. In the denominator, when you open the bracket, minus 1 and plus 1 will cancel. So sine x plus sine x, minus minus is plus here. So sine x plus sine x, so the denominator will be 2 sine x. In the numerator, this 1 plus 1 will be 2 as well. So what you get is cot inverse of 2 plus 2 into root of 1 plus sine x into root of 1 minus sine x. Under one root sign, I will read it like a plus b into a minus b, which is a square minus b square. So 1 plus sine x into 1 minus sine x is 1 square minus sine square x. So once again, 1 plus 1 is 2, then plus 2 into root of a plus b into a minus b is a square minus b square, 1 square minus sine square x. Divided by denominator is sin x plus sin x is 2 sin x. So in the next step, what would happen is this 2 common factor, if I take out, it will cancel with the denominator, and 1 minus sine square x is cos square x. So it's going to be cot inverse of 2 into, I'm taking the common factor out of the numerator, so 2 into 1 plus 2 is taken out, root of 1 minus sine square x cos square x, root of cos square x is cos x. 1 minus sine square x becomes cos square x, root of cos square x is cos x, divided by 2 sin x. 2 and 2 will cancel. So I have cot inverse of 1 plus cos x, but 1 plus cos x is 2 cos square x by 2. Sin x is 2 sin x by 2 cos x by 2. So half angle formula for both numerator and denominator. 1 plus cos x is 2 cos square x by 2 divided by sin x is 2 sin x by 2 cos x by 2. 2 and 2 will cancel. Cos x by 2 and 1 cos x by 2 will cancel. Balance will be cos x by 2 only in the numerator divided by sin x by 2. So this is cot inverse of cot x by 2, because you cancelled cos x by 2 with 1 cos x by 2 in the numerator. 2 and 2 you cancelled. So cos x by 2 by sin x by 2 is cot x by 2. Cot inverse of cot x by 2. Cot inverse and cot will cancel. So it's only x by 2 now. So that's my question. Y is equal to x by 2. So this is my question simplified. The question is actually to differentiate. Therefore, dy by dx would be derivative of x by 2 is 1 by 2. We have another question here now. So this is y is equal to tan inverse of cos x divided by 1 plus sin x. Y is equal to tan inverse of cos x divided by 1 plus sin x. So in this question here, when I look at this question, what I would notice is that I have a 1 plus sin x in the denominator, and 1 plus sin x has got no formulae available. But I know that there is a formula available for 1 plus cos x. 1 plus cos x is 2 cos square x by 2. So since it is 1 plus sin x, I can't apply the formula. So I know what is to be done. I have to change this sin x into cos something. Sin x is equal to cos of, we know that 1 plus cos x has a formula and sin x has a half angle formula. So what I'm going to do is I want to make the denominator look like 1 plus cos x. How would I get that? Sin x can be written as cos of 90 minus x. Sin x is equal to cos of pi by 2 minus x. So if I take out sin x and write cos of pi by 2 minus x, the denominator will look like 1 plus cos x. But if I change the angle in the denominator, I have to change the angle in the numerator as well. So I'll change cos x into sin of pi by 2 minus x. So that's what we are going to do here. So y is equal to, instead of cos x, we'll write sin of pi by 2 minus x divided by, denominator is 1 plus, instead of sin x, we write cos of pi by 2 minus x. Cos 90 minus x is sin x and sin 90 minus x is cos x. So we change cos x into sin of pi by 2 minus x divided by 1 plus sin x we rewrite as cos of pi by 2 minus x. Now for both numerator and denominator we have half angle formulae. So this is tan inverse of sin theta. Sin theta is 2 sin theta by 2 cos theta by 2. Sin theta, 2 sin theta by 2, half of this angle. Take half of pi by 2, pi by 4, minus half of x, x by 2. So you take sin theta becomes 2 sin theta by 2 cos theta by 2. If your theta is pi by 2 minus x, theta by 2 would be pi by 4 minus x by 2. So 2 sin theta by 2 cos again theta by 2. So pi by 4 minus x by 2 divided by 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2. So the denominator would be 2 cos square half of this angle, which is pi by 4 minus x by 2. So 2 cos square pi by 4 minus x by 2. So this 2 and 2 will cancel. Cos pi by 4 minus x by 2 and one of the terms cos pi by 4 minus x by 2 from the denominator will cancel. So this cos and one cos from the denominator cancel. Balance is sin pi by 4 minus x by 2 by cos pi by 4 minus x by 2, which will be tan pi by 4 minus x by 2. Now tan inverse and tan will cancel. So I have pi by 4 minus x by 2. Now I am in a position to differentiate. Therefore dy by dx is equal to pi by 4 becomes 0 and minus x by 2 becomes minus half. So you have a question for homework here. Y is equal to tan inverse of sin x divided by 1 plus cos x. Because you know what is to be done, 1 plus cos x has a direct half angle formula, so it is easier than the one which we just finished. So 1 plus cos x will be 2 cos square x by 2 and sin x will be 2 sin x by 2 cos x by 2. So you take these two formulae and sub it in here and you will be able to do it. This is also a direct question. Okay, so please do the homework, practice all these questions one more time, and then we see in the next video.